Okay, so here we are with part 2 of this circuit worksheet video, and this is the last page in the 3-page packet. And here we have a pretty complicated circuit. Just want to point out a couple things. This is the battery, it's 1,000 volts. Resistor 1 and resistor 5 are actually in series with each other, even though they look like they're across. So it's kind of misleading that they're in series, but if you think about how they are connected to the battery, there's only one path to get from R1 to R5, and that's through the battery. If we went this way, the electrons would have to split, but they'd all come back together again. So R1 and R5 are in series with each other. R2 is in parallel with R3 and R4. And R3 and R4 are actually in series with each other. So for 29, what's the combined resistance of R3 and R4? These are in series, so we just add their values together. So that's going to be 400 ohms plus 200 ohms, and that's 600 ohms. So that's the resistance for that branch. Now, what's the combined resistance of the parallel setup? Well, this side, R2, is in parallel with both of these, but they're in series, so they're like one 600 ohm resistor. So the combination that I'm going to get when I add these together, I have to use the rule for resistors in parallel. I'm going to take 300 ohms to the minus 1 plus this combo is 600 ohms to the minus 1, and all that's to the minus 1 power. And when you do that, you get 200. So that whole parallel branch from A to B, this whole thing is like one 200 ohm resistor. Okay, next thing, combined resistance of R1 and R5. Well, because they're in series with the battery, then they're in series with each other. So R1 comma 5 is just R1 plus R5. So that's going to be 500 ohms plus 300 ohms. So that's equal to 800 ohms. So now what's total resistance of the circuit? Well, from A to B, that's just like a 200 ohm resistor that's in series with R1 and R5. So you just add them all up. So the total resistance is going to be R1 plus that combination of 3 resistors plus R5. So it'll be 500 ohms plus 200 ohms plus 300 ohms. So that's equal to 1,000 ohms. So what's total voltage of the circuit? Well, that's right on the battery. So that's the total. So you just write that down. That's your proof. So it's 1,000 volts. Total current in the circuit. So we know the total voltage and total resistance. So we can use Ohm's law to find the total current. So that's going to be 1,000 volts divided by 1,000 ohms. So that's 1 amp. All right, half done with this problem. Next, what is the voltage drop across R1? So we're looking at what voltage is lost at this resistor, at the 500 ohm resistor. So we know the current through it is the total current for the circuit, which is 1 amp. So I can say V1 is equal to I1 times R1. I have to solve for current. And I already know the current because it's 1 amp. So it's just going to be 1 amp times 500 ohms. So that's 500 volts. So we lost 500 volts of energy at that first resistor. Okay? So we can use the same setup defined for the 300 ohm resistor. So that's V5. And the current through it is the same as the current in the first resistor. So it's 1 amp times 300 ohms. So that's 300 volts. So if you think about it, if we go up 1,000 volts and we drop 500 volts here and 300 volts here, then what's left is the difference, which is 200. So what I just did in my head is this: V2 equals the same as V3 plus 4, and that's the total voltage, minus V1 minus V5. So that's 1,000 volts minus 500 volts minus 300 volts. So it's equal to 200 volts. What's the voltage of R2? Well, we just found that. That's what remains to be lost from here to here. So V2 is 200 volts. All right, now that we found the voltage in that resistor, we can find its current. So I2 is equal to V2 over R2. V2 is 200 volts. R2 is 300 ohms. So the current is 0.67 amps. And the current there splits. We had 1 amp coming in, 0.67 goes this way, so that means through R3 and R4, the rest of the current has to go through that. So what we'll find out is it'll be 0.33. So I3 and 4, they have the same current because they're in series. So that's the voltage of their combined resistors, and then divided by the resistance of their combined resistors. So the combined voltage was 200 volts, because that's parallel to R2, and then the resistance is 600 ohms, and look at that, that's 0.33 amps, just like I said earlier. Physics works again. A couple more to do here. What's the voltage of R3? Well, we know the current through R3 now, so now we can find its voltage. And this voltage and the voltage of R4 have to add up to be 200, which is what the voltage for R2 is. So here we go. So V3 equals I3 times R3. So that's 0.33 amps times 400 ohms, and that is 133.3 repeating volts. Okay, now we have to do R4. Well, if this is 200 and we found that was 133, then this has to be the rest for that. So V4 equals I4 times R4. So I4 is 0.33 and R4 is 200. So that'll be 66.67 volts. And look at that. These two add up to 200. Cool. All right, now, what's V1 plus V2 plus V5? Well, V1 plus V2 plus V5 would be 500 plus 200 volts plus 300 volts. And that equals 1,000. And then V1 plus V3 plus V4 plus V5. What's that equal? So that'll be 500 volts plus 133.33 plus 66.67 plus 300, and that equals 1,002. So the question is, what's that? Does it equal that? Yep. Does this equal the total voltage of the circuit? Yes. And there you have it. The circuit worksheet completed in 2 parts. Have a nice day.